The biggest trick with scholarship physics questions, or any high-level physics question, and especially real-world physics questions or problems, is that you have to read the question very carefully. You have to look at the background, and you have to apply a few cognitive skills, thinking skills, to the process. So for instance, this question here, we have the flute being played by blowing air over a large opening at the left-hand side of the end there. And then we've got a clarinet, which is also played by blowing through air over opening. It's a small opening and it's covered by a vibrating reed, similar to a saxophone and other reed instruments. But now this main cognitive skill here is as soon as we've got two things, one there and another there, two things brought to the table, as it were, we should be comparing them and contrasting. So strategy, we should compare and contrast. Comparing is looking at things that are the same, and contrasting is looking at things which are different. So a large part of this is clear and straightforward because there's not a lot of information at this point, but we've got the names clearly. The flute is different from the clarinet. They're both played by blowing air over an opening, but for the flute it's a large opening, and it's a small opening for a clarinet with a vibrating reed. So yeah, those could be important bits of information. Now we should also consider the physics principles that we know of, and this is to do with musical instruments and standing waves. Anything where you're producing music or notes, or whether it's string, wind or other, it's to do with standing waves. Anything with a coherent, constant note. And these are both playing notes, but using our knowledge of standing waves, we have to think about how they're the same and how they're different. Yeah, one of them has a large opening, one of them has a small opening, as we've seen, so that would indicate that one of them is going to be an open pipe, or modelled by an open pipe, and one of them will be modelled by a closed pipe. And with the small opening, it looks more like a closed pipe for the clarinet. Okay, so that's the first thing. Now that we've put this into a physics context that we know of, we can start looking at the question in more detail. So that's the first thing. We've found, let's make that clear, we've found that the flute is an open pipe and the clarinet is closed pipe, and they'll be modelled by the various waves that you see in you studying in year 13, 7th form, final year of high school, whatever your particular system is. So anyway, moving on, the acoustic pressure in these wind instruments is the difference between the air pressure inside the instrument and the atmospheric pressure outside. So yeah, when the acoustic pressure is measured inside the flute and the clarinet, the maximum and minimum pressures are found to vary along the length of the instruments, as shown in the following graph. So, and then it says about the length of them, where the opening is. So we need to think about how this pressure produces the sound and the standing waves inside of the flute and the clarinet. And if you haven't learned it, you should know that the particles vibrate backwards and forwards at each location. There are points which we would call nodes, which are areas of minimal vibration, so the smallest amplitude. I'm not certain, I don't think they are, but I'm not 100% certain that they are not vibrating at all at a node, but they are definitely the smallest amplitude. And you have antinodes, where the particles vibrate the maximum amount. Okay, so if we're looking at this pressure graph here, we could very quickly look at it and go, well, there's a maximum pressure. That means there will be an antinode where there's maximum movement, but it's actually the opposite, because if you think about it, the more pressure that you apply to the air inside the column, so more pressure, that would lead to less movement. Okay, think about why that is. if you've got more pressure, there'll be less movement. Why? It's because the air particles that are under pressure do not have as much freedom to move, clearly. It's like if you were squishing down on, you can think yourself, if you had a great weight pushing down on your back and shoulders, you're bent over, hunched over, and you can't move as much because you've got more pressure on you. But if you've got less pressure on you, say you go to the moon where you've got 1/6 the gravity of Earth, you can move a whole lot more. Okay, so these high pressure ones over here, just thinking ahead, that's going to correspond to a node. Okay, and these low pressure ones in the middle here, that's going to correspond to an antinode. Really important. So this diagram could very easily mix you up because it looks very similar to these sorts of diagrams that we see representing the amplitude of the particles as they're in their motion. So it's not the same. It's definitely not the same. Okay, now we've come to the end of all of the introductory material. We're going to move on to the first question and go from there. So the first question says, explain why at each point inside the instruments the pressure is recorded as having both a positive and negative value. Well, we've already talked about this just a little bit. Remember, the particles of air are vibrating backwards and forwards, so that would indicate that that the particles are under both a positive and a negative pressure, depending which way. So if you look at the column of air compared to atmosphere, I don't know, there you get the idea. Atmosphere, there's going to be a positive pressure at some point pushing the air at the opening in that direction, and then it's going to change and go in the other direction, and the air will move back the other way. So that's your positive and negative pressure, and you would have to craft a very careful sentence to explain that. And what you can always do is go have an attempt at it, draw a few diagrams, and then go look at the answers that are provided and test whether you got that right. Some important ideas. That you'd have to maybe mention that it's a longitudinal displacement, so that also gets in your mind thinking that the air is moving with respect to this diagram to the left and to the right, or to the right and the left as I drew it, and so longitudinal, it's very important, and because remember, our diagrams that look like this, that's only a representation of the amplitude in a familiar form, similar to a sine graph or something like that, to show where the amplitude is moving with respect to the equilibrium position. That's what this is showing. This up here is showing. So it's not saying the particles move up and down, it's saying they move side to side, but it's just illustrating the amplitude. And those positive and negative displacements correspond to positive and negative pressure, which makes sense. More pressure pushing in at the opening, the more that it's going to compress, and the less pressure at the opening, the more it's going to go the other way. Rarefact. But yeah. That's all for the first one. Next one coming up.